Hi, my name is Will Pincek. I'm with Education Services at Juniper Networks, and I'm about to do a learning byte on Contrail Enterprise Multicloud using the fabric management features. And we're going to do multi-home. We're going to bare metal server multi-homing using a bonded interface. Okay, and what exactly is that? This is where, what is that use case? Okay, this is going to allow for the physical high availability of a bare metal server, and the bare metal server will be configured with a bonded interface. That is, it's got two physical interfaces that are going to be bonded together to do link aggregation. In this scenario, LACP, link aggregation control protocol, must be enabled. Because the top of rack switches will be enabled for that automatically during the configuration that Contrail Enterprise Multicloud does. So the bare metal server has two interfaces. Those two interfaces will attach to, well, in our case it's two, but it could be more, but our two interfaces will attach to two different top of rack switches. And those top of rack switches will act as VXLAN layer 2 gateways. And one of the nice things, the main benefit for using Contrail Enterprise Multicloud is that Contrail Enterprise Multicloud will automatically configure those top of rack switches for the VXLAN overlay, which is the hard part of the whole thing. Okay. So what are we looking at? Now I start here in this area. We are trying to attach a bare metal server to an overlay network, so a Contrail overlay network, 192.168.1.0/24. Okay, and then we don't have to do this, but we're also going to do central routing through the QFX10K, our physical QFX10K, and get internet access for this bare metal server. Now this bare metal server shows one connection here, but it's actually two into this virtual network. Okay, and so the literal physical topology looks like this. Okay, where we have the bare metal server with two Ethernet interfaces. Each interface goes to two separate QFX 5100 top of rack switches. The bare metal server is going to have a lag interface or bond interface configured, where these appear to be a single interface to the bare metal server, and it will load balance across those, and it'll be able to recover if a link fails. There will be at least one up, right? So this is for high availability. The protocol LACP will run between the bare metal server and the top of rack switches. And then what Contrail Enterprise Multicloud will do when we go through this process is we'll automatically build the bridge domains and the VXLAN overlay tunnels up to the QFX10K, and will automatically configure the QFX10K to be able to route out to the internet as well. So here we see this slide's bridging on the leaf. So what happens here is that the Contrail Enterprise Multicloud will configure these bridge domains, associate them with the VXLAN tunnels, and also enable the EVPN signaling that needs to happen between devices. And then it will also, just because EVPN is being used to prevent loops, because this is a potential loop, EVPN automatically protects against the loop that could happen here where we send traffic out here and have it happen to come back this way. That's prevented using EVPN type 4 routes, which is just part of the EVPN protocol that read on that back. So we don't have to worry about a loop here. Okay, it's already done, and we don't need any spanning tree to protect against that or multi-chassis lag. That's unnecessary here. EVPN takes care of that. And so these two devices will automatically get configured in our situation by Contrail Enterprise Multicloud. And then because we're trying to get internet access through this logical router, the QFX10K will also get magically configured by Contrail Enterprise Multicloud, which is on the next slide here. Okay, which is here. Okay, so here's those two VXLAN tunnels that we saw coming in from QFX 5100 1 and 2. They both will terminate on VNA a bridge domain here on the QFX10K, which is what we're looking at. This big box is the QFX10K. It's got a default switch, Ethernet switching table, and that's where those VXLAN tunnels will terminate. Now, why will they terminate there as opposed to the routing instance? That's because if we go back a slide, we have it's the QFX 5100s that only support the Type 2 advertisements. If they supported Type 5s, you would see that these tunnels end up terminating on the routing instance instead. And I do have a learning byte on central routing with the QFX10K, so you can go into more detail there about that. But here we'll assume that you've already watched that. We see that these VXLAN tunnels terminate here. So any traffic that comes inbound from these VXLAN tunnels, as long as they're destined for the gateway, which is 192.168.1, which is the IP addresses of this IRB interface, that traffic will get the layer 2 headers will get stripped, and we'll do a routing lookup on the IP table here. Here we see to get out to the internet, we'd use the default route, which says, okay, route on this table inet0, which routes out this way. On the way back, for any traffic coming back, it'll get routed based on a firewall filter that says for any traffic destined for 192.168.1.0, then use the layer 3 VPN table, which this should say destination address. So let me go ahead and fix that. So anything destined for 1.1.0, forward it based on this routing table, and then anything destined for the 192.168.1.0 network, go through IRB5 and then forward based on this Ethernet switching table down here. And then eventually it'll hit the appropriate destination. So that's what we're looking at. Now to make this all happen, you need some prerequisites, right? So some of these things already have to be in place. We need a bare metal server configured with bonded interfaces or a lag interface. We need a Contrail cluster with the Contrail command user interface in place. That has to be there existing. We need VXLAN routing enabled to do that logical router stuff on the QFX10K. And then we also need an onboarded IP fabric with EVPN VXLAN overlay signaling already established. And this happens when you do a greenfield or brownfield onboarding. I do have learning bytes on brownfield and eventually greenfield. And then also, when you do that onboarding, you have to assign roles to your spine and leaf nodes. You need to make sure that the spine nodes are assigned the CRB gateway role and the DC gateway role, and the leaf nodes need to be assigned the CRB access roles. So here's what we're going to have. Our current topology that we're about to work with has this topology. We've got an existing Contrail cluster, which are these 5 nodes down here. Okay, we have an OpenStack orchestrator node. We've got a Contrail control node. We've got 2 OpenStack compute / Contrail vRouter nodes, compute 1 and compute 2, and then we also have a CSN that can provide DHCP and DNS server services for any bare metal servers. Okay. And then we also have the command server, which hosts the command UI enabled. We have done a brownfield onboarding of this IP fabric, and because of that, because this guy is a route reflector for this overlay network, you'll see that we have EVPN sessions built from the control node to the QFX10K, from the QFX5101 to the QFX10K, and to also to between these two as well. So those should be established. So what we're going to do is we're going to, let's see, again, this is established. We are going to try and get this up and running, which is this here, okay? So first we want to verify a few things. So let's do that. We go to, let me bring up my list. Here's the steps I want to go through. Okay, I want to verify the bare metal server interface bonding. So on my bare metal server, which I have here, if I say show configuration interfaces, now my bare metal server is an EX switch, okay, that I have as a router with lag interfaces configured. I've got my ET012 and 013 interfaces acting as members of the AE0 aggregated Ethernet interface. On that aggregated Ethernet interface, I have it's named AE0. I've got LACP turned on, and I've got my IP address. I've got a static IP address set up, which matches our diagram here, which is the .30 address is on that interface. Okay, so that's exactly what we have, LACP turned on. Now, if I look at those interfaces, okay, if I look at the status of those interfaces, show interface terse, I'm going to see that my AE interface is currently down, and that's because the LACP has not detected a neighbor downstream. So that's because the QFX 5100s have not been configured yet, and that's what Contrail Enterprise Multicloud is going to eventually do for us. Okay, so we've done that. We want to verify MPBGP. So remember, our QFX 10K. Our QFX 10K is acting as a route reflector of for our EVPN sessions. So let's go there to our 10K. Here's our QFX 10K. Exit out. If I say show BGP summary, and this is all because we did a brownfield onboarding, it automatically configured my EVPN sessions. There's one here established to QFX 5101. Here's the one to 5102, and here's the one to the control node, the Contrail control node. Okay, so that's already established. We also have our underlay, which is an eBGP underlay to provide the routing for all this traffic, this VXLAN traffic that's going to happen. So we've verified that. So that takes care of that. We want to verify our CRB roles. Okay, we want to make sure that our fabrics have been assigned, or the fabric nodes have been assigned the right role. So if we go here under our brownfield fabric, okay, infrastructure fabrics brownfield, I've got my devices here. I've got my QFX 10K and my two QFX 5100s that were onboarded. The QFX 5100s have the CRB access role. That's great. The QFX 10K has the route reflector role, DC gateway, and the CRB gateway role. So we're good there. Okay, so we verified that. We want to verify VXLAN routing. To be able to support that logical router functionality on the QFX 10K, we have to have VXLAN routing enabled. So we go over to Projects, Admin, and here we want to make sure that this slide button has been enabled, and it has, so we're good. We want to verify also that the CSN has been assigned to our CRB access devices, because remember, if we're going to add a bare metal server and it happens to need DNS or DHCP services, we need a CSN out there. So there is a CSN hanging off of here, which we have. If I show it here, I have a CSN off of QFX 5101. I need to assign the CSN to these top of rack switches. Don't really need it in this scenario, but I want to make sure that it is assigned. So let's go over there, and we go back to our fabric. We go to our brownfield fabric, and here we go under Edit for our first 5100. And it turns out I've already done this, but I've assigned a top of rack service node, and the TSN I assigned was the CSN node. So that's been done. We're good. So we go back to and we double check it for QFX 5102. Which is where we need it also, and sure enough, it's already been assigned. So that needs to be in place also before we onboard or bring on this bare metal server. We want to modify the default security group to allow inbound traffic into this bare metal server, right? So this is part of the security for Contrail. So we go over here and go under our default security group, because this bare metal server is going to get assigned to the default security group. So I go over here and I need to modify in the egress direction, we're good. We're allowing all traffic out. That's what we're seeing here for all traffic from 000 or 000 for IPv6. We're allowing it out, but we're not allowing anything in. So we have to go here, modify this to CIDR, and specify all, which it does by default. So this says for all ingress traffic is going to allow all ingress traffic in from no matter what IP address. I'm going to also do it for IPv6, although we're not doing IPv6 in this learning byte. Here I'll click Save, and now we've modified our default security group to allow all ingress traffic. Now I need to create the virtual network. Remember, our virtual network was VNA. If I go back here, virtual network A is what we're trying to enable, right? So we're going to set that up 192.168.1.0. Okay, so I'll go do that. I'll go under here under virtual networks, create a new virtual network called VNA. Okay, no policies are necessary here, and we just need to create a new subnet using the default IPAM subnet. here. I'm not actually going to do DHCP and DNS, but I'm going to allow it anyways. My gateway, this will be the gateway IP address of the IRB interface, so you make sure that's the way you want it, and hit create. Okay, so now we've got that. Now we've got our virtual network. Now, create logical router. This is optional if we were just going to do layer 2 switching between bare metal server and maybe VMs. But in our case, because we're going to do routing on the 10K itself, we need to enable a logical router there. So that scenario, we'll need to do that. So we go over here to overlay, go to logical routers, say create. We're going to call it LRA, logical router A. Okay, and the network we're going to extend it to the QFX 10K. The network we're going to extend it or connect to it is VNA. Okay, and it's going to be public because we want it to be able to route out to the internet. Okay, so it'll do that routing between tables. So we'll create it. So that gets created. Great. Then we need to create our bare metal server. When we do this, we go under here under servers, and we're going to select create. Now the purpose of this, when we create our bare metal server, is the whole idea is we're going to map the bare metal server to an interface on our to our top of rack switches, okay, and also list the MAC address of the device as well. So here we go to we're going to create a bare metal server called BMS, okay. The network interface, we're going to call it ET012. We need to specify the MAC address of ET012. So let's go back to our bare metal server. Show interface ET012. It needs to be the actual MAC address, which is here. Okay, current address. So that needs to be the one we place in there. Okay. Okay, and what interface will it be associated with? Well, if you remember, it was ET0050 of the QFX 5101. Okay, boom. Okay, we're going to add another one. Okay, and this is going to be ET013, and we need the MAC address of ET013. So let's get that. ET013 is this one. Okay. Okay, so we'll place that in there. And then that's going to be associated with QFX 5100 to the ET050 interface. Okay, now because it's bonded, it looks like a single interface. We're going to specify a port group. This is going to allow it now. This is going to cause it to configure the LACP for it. So we're going to call this one AE0. Okay, it doesn't have to match. These names don't actually have to match what's going on the real devices themselves. It's the MAC address that does have to match it. This has to match. Okay, so we want to associate it with that interface and that interface. So there's our two bonded, or our two member interfaces of that aggregated Ethernet interface. Now we're going to hit create. All this is going to do is just associate these ports to the bare metal server's interfaces with and specify. We're also specifying the MAC address that it should be expecting to see, and also the supported or the member interfaces to the aggregated Ethernet interface there. But it won't actually go out and configure anything at this point. Okay, you're just kind of setting a placeholder. In order to get this to work and have it go out and configure things on the actual top of rack switches, you have to go to instances and launch this bare metal server instance. So we're going to go here, and this is where we're going to assign IP addresses and things like that. So here we're going to create a new instance. It's going to be an existing bare metal server. We're going to give it a name. We'll call it bare metal server. The bare metal node is the BMS that we just configured, okay, which will allow this drop-down box to work. So here it'll show my interface, AE0. What's our interface? Now that interface, if I leave it empty, it's going to try and get an IP address from DNS, okay, but in our case, we have a pre-configured one 192.168.1.30. So if I say show configuration interfaces, notice that 1.30 is already configured on that aggregated Ethernet interface. There'll be no VLAN tagging. Okay, the virtual network will be VNA. The security group will be default. Okay, so that's why we had to change our default security group. And now we'll hit create. The moment we do this, the device manager on the control node is going to go out and configure those top of rack switches. So I'm going to hit create. Okay, so to watch this all go down, okay, we see that it's working. We want to make sure it's working. Okay, so it's working. It says it's done, but it's really not. So I go to the control node, and I want you to see this. The command I use on the Contrail control node to watch what's going on is to do a tail -f on var log Contrail fabrics Ansible playbooks.log. And here we see this is the Ansible playbooks are running, and it's building the configs right there on the control node, and then it's eventually going to push those configs out to the top of rack switches. So we have to wait for that to complete. So I'm going to go ahead and pause this video until it completes. Okay, so it's finally completed. We see this here. This nothing failed. Everything looks good on the Ansible playbooks. So at this point, the QFX 5101 and 2 have both been configured for acting as layer 2 VXLAN gateways. So if I say show pipe compare rollback 1, it'll show you what's been configured, right? We see here that we've got VNI 5 is being used, so VXLAN ID network ID identifier 5 is being used and associated with a target. There's been some policies configured. There has been a modified VRF import policy. We've had the aggregated Ethernet interface enabled, okay, and we have a VLAN set up and associated with that same VNI. We've got aggregated Ethernet, aggregated devices turned on the chassis. We've got LACP turned on the aggregated Ethernet interface, and we've associated a single member to it, which is ET0050, which is the attaching interface. Everything we wanted is there, okay? And if I had to look on the 5100 too, it would be the same thing. So it turns out, oh, and we also have an ESI configured, which is going to allow us to prevent loops, okay? A non-zero one is going to be used to help prevent loops, okay? And good enough. I think we're good there. Now, if I go down to the bare metal server now, and remember our aggregated Ethernet interface was down before because of LACP. Now we see that it's up. It's now up. Can we ping the IRB interface of the QFX 10K, which is the gateway address? Sure enough, we can. And so the last bit is, can we ping the internet, which is what we wanted to do. So let's just ping www.juniper.net. That didn't work because it was defaults to a v6. So here's a v4. So sure enough, it works. And that's it. That's how you do BMS multi-homing using a bonded or link aggregation interface. I hope that helps. Let me bring this up. Let's talk about here. Let's so back to our slides. So in here we describe the steps to use Contrail Enterprise Multicloud to help attach a multi-home bare metal server to an IP fabric. With that bare metal server having a bonded interface or a link aggregation interface. I hope that helps, and look for some more of my learning bytes coming up.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Network's certification program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.